Hello everyone, my name is Jonathan White and welcome to this YouTube video. I'm currently studying applied cybersecurity within the University of South Wales, but they've asked me to present a 10-minute video on the OSI layers. Right, so the OSI layers themselves are mainly split into 7 layers. It goes from 7 to 1, and when it's received at the other computer where it's communicating, it will build it back up from 1 to 7. The two main groups within these 7 layers is the top group and the bottom layer. So the top layer itself is more software based and the bottom layer is more hardware assisted. The model actually uses layers to help give visual description of what is going on with a particular network system. So this can help network managers narrow down certain issues, whereas let's say there's an issue with a network layer, they can ascertain what is used in the network layer and sort out the problem. So tech vendors selling the products also use the OSI model to help customers understand which layer their product works on. So these models are mainly used to allow companies to build to a certain degree so all communications can use this model and work efficiently. So if we move on to the 7 layers themselves, the first layer, or should we say the 7th layer, is actually application. Our application provides its users with an interface to send and receive the data. It is what the users see on the screen and actually interact with. So this would be things such as your internet browsers like Google Chrome or Firefox. It also uses protocols such as SSH and the mail transfer protocol, so you'll be able to see Outlook and applications such as Skype within this layer. So from layer 7 we then move on to layer 6, the presentation layer. Now the presentation layer is mainly responsible for the decryption, encryption, conversion and the compress of data. It basically works as a translator. So the two communicating devices communicate using encoded methods, but what happens if they're different? This is what layer 6 comes in for. Layer 6 is responsible for translating the incoming data into syntax that the application layer of the receiving device can actually understand. If the devices are communicating over encryption, layer 6 is responsible for adding the encryption in the sender's end and decoding it on the receiving end. And finally, the presentation layer is also responsible for compressing the data it receives. So basically it makes it smaller and a lot faster to be sent and transferred to the other computer. From the presentation layer, we'll then move on to layer 5, the session layer. The session layer is responsible for opening and closing the connection. So once it's received the compressed data from the presentation layer ready to be sent, the session layer then opens the connection with the other device and keeps it open until the whole information is sent. It also sets checkpoints, so if the communication is broken at any point, it can go to the last checkpoint it has sent and it can resume from there instead of having to send the whole data again. Once the receiving computer receives all the information and data that has been sent, it closes the application promptly in order to avoid wasting resources. Layer 5 is also the last layer of the top layers. Now the information stored in these top layers is also known as data. Now this data is important for the encapsulation process. The term encapsulation and decapsulation refers to a process in which protocol information is added to data and removed from the data when it is passed through the layers. Encapsulation process takes place from the sending computer and decapsulation process takes place from the receiving computer. After encapsulation, each layer uses a specific name or term to represent the encapsulated data. Now, with the top layer, it's all known as data. Now, when we move through the lower layers, I will show and explain what happens to this data through the encapsulation process and the terms and names given to each method. So if we move on to the lower layers now, the first layer is layer 4, transportation. Now these are broken down into three major points. We've got the segmentation, data transportation, and multiplexing. The segmentation is when the sending PC breaks down data into the smaller pieces. So it takes the data from the top layers and it actually separates them into segments. The receiving computer will rebuild these segments into data. Data transportation. This layer establishes a logical connection between the sending system and the receiving system and uses that connection to provide end-to-end data transportation. There's two main protocols used in this. It's TCP and UDP. Now, if you think of TCP as a more reliable way of transporting the data, it basically sends a segment off, asks the computer if they received it, they say yes, and then it sends the next one. Whereas UDP just fires it as fast as it can, which is more useful for stuff like streaming movies, as it would send it at faster speeds. So the final major point is multiplexing. So through the use of port numbers, this layer also provides connection through multiple applications. This will allow the ports to send and receive multiple data from different applications simultaneously. So as we mentioned with the top layers, the information is known as data. Now part of the encapsulation process within the transport layer means that the data is split into segments, and each one of these segments will actually have a transport header. These headers contains all the necessary information about the pieces that the transport layer and remote host needs to reassemble the data stream back from the pieces. Once the header is actually attached, the data is then referred to as the segments. Once the segments are created, they are handed down to the network layer for the further process, which this is now layer 3. So the next layer, layer 3, the network layer, it splits the segments mentioned previously into packets. We'll go more into that in a second. It adds local addresses onto them, which holds the network partition and host partitions, and it holds the logical address known as IP addresses. A device normally found on this layer is the router. So the network layer is actually responsible for facilitating data transfer between two different networks. However, if the two devices communicating are on the same network, then the network layer is completely unnecessary. So we now know that the information from the data is actually split into segments. Now these segments are now split into packets. The network layer creates a header for each received segment from the transport layer. This header contains information that is required for addressing and routing, such as the source software address and destination address. After this information is actually added, the segments are transferred into packets. This is then passed down to the next layer. The next layer being layer 2. Now, layer 2 is the data link layer. The data link layer is very similar to the network layer, layer 3. Like the network layer, it's responsible for facilitating data transfer. However, the network layer does it between networks, whereas the data link layer actually does it between two devices on the same network. So if we go on to the encapsulation process of data link layer, we already know that from the previous layers it goes from data to segments with packets with extra information being added in the front. Now with the data link layer, it adds a frame header as well as a frame tailer, so it puts it at either end. The header contains information that is required for switching, such as source hardware address and destination hardware address. Now the end bit, the trailer, contains information that is required to detect and drop corrupt data packages in the earlier stage of de-encapsulation, so it is when it is received on the other end. Once either end has been added with a frame, it is actually referred to as a frame from then on. Frames are then passed down to the next layer. The next and final layer is layer 1, the physical layer. Now the physical layer is where the physical equipment gets involved in the data transfer. Now, this is such things as the cables and switches. Also within the physical layer is where the data gets converted into a bit stream. Now this is where it is converted into strings of ones and zeros. It converts information into a format that both devices must agree upon. So for example, if the host is connected to a copper wire, the physical layer must convert it into voltage, and the receiving computer must also be able to convert it, knowing which ones are the ones and which ones are the zeros. So if we have a look at the encapsulation process within the physical layer, we can see that it's already gone from a data to segments to packets to frames. Now it gets converted into the bits. Now not forgetting that this is converted into a media format that both computers can actually recognise. So as I mentioned before, if it's via copper wire, it'll be converted to voltage, whereas if it's wireless network, then it'll be converted to radio signals. Now that the physical layer is explained, there is all the 7 layers of the OSI model explained. So if we move on to the de-encapsulation process, we will find out what happens when the information is received on the other side. It's first received in the physical layer, so the first layer, and goes up to layer 7. But within the physical layer, it is received in its bit stream format. The physical layer then encodes the signal from the media and converts them in frames and hands them over to the data link. The data link layer first reads the trailer frame to confirm that it has been received in the correct shape. It reads the rest of the frame only if the frame is in the correct shape. If the frame is fine, it reads the destination hardware address to determine where it should go. If the frame is intended for that system, it will remove the header and trailer from the frame. Once the data link layer header and trailer are removed from the frame, it becomes a packet and is handed over to the network layer. The network layer then checks the destination software address and the header of each packet. If the packet is not intended for it, the network layer will discard the packet immediately. If the packet is intended for it, it will remove the header. Once the network layer header is removed, the packet will become a segment and therefore hand over to the transport layer. The transport layer then reads the transport headers to determine which segments go in which order. Once this has been done, it is transferred into a data stream and handed over to the upper layers, or the top layers. The top layers format the data stream in such a format that the target application can understand. And this concludes how the information is sent and received through the encapsulation and de-encapsulation process. If we move on to the conclusion now, you can see we've covered the 7 layers of the OSI model: application, presentation, session, transport, network, data link, and the physical layer. We've also covered the encapsulation and decapsulation of the OSI model. So I'd like to say thank you very much for watching my video. My name is Jonathan White, and thank you.